Welcome to EDU World Space.
For this question, we have to calculate change in enthalpy of vaporization for each of the liquid. So let me write the basic formula. Change in enthalpy delta S of vaporization will be equal to change in temperature of vaporization divided by temperature. So starting with first acetone, we have CH3 2 CO. Substituting the values into this given formula, we have 29.1 kilojoules per mole Kelvin divided by 329.1 Kelvin. This gives me enthalpy of vaporization as 88.4 joules per mole Kelvin. Calculating the same for second, we have dimethyl ether CH3 2 oxygen, which is 29.1 divided by 248.2. The value turned out to be 88.6 joules per mole Kelvin. Secondly, now we have ethanol C2H5OH. It will be 38.6 divided by 351.4. So enthalpy will be 109.8 joules per mole Kelvin. Continuing the same for octane, we have C8H18. Substituting the values, 4.4 divided by 398.6 gives me 86.30 kilojoules per mole Kelvin. Now pyridine, we have C5H5 nitrogen. It will be 35.1 divided by 388.3, giving us 90.4 joules per mole Kelvin. So this is the A part. Now part B, we have Trouton's rule is not followed by ethanol. So not followed by ethanol since the intermolecular forces between the molecules are too strong because of hydrogen bonding. Moving towards option C, water is not expected to obey Trouton's rule because of strong intermolecular force and hydrogen bonding. So using the same formula, we have delta S equals 40.67 divided by 373, which gives us the value 1.090 multiply 10 raised to power joules per mole Kelvin. The enthalpy of vaporization at 100 degrees Celsius will be equal to 40.67 kilojoules per mole, while entropy delta S of vaporization will be 109 joules per mole Kelvin. Part D, we have to calculate the enthalpy of vaporization of chlorobenzene. So we are already provided with the delta S and temperature. So substituting that, delta H will be equal to delta S multiplied with temperature. We have value of S equals 88 and temperature is 404.8 Kelvin, which gives us enthalpy as 36 kilojoules per mole.